This is two-part problem solving where we have both an accelerated motion and a constant motion. Okay, the first problem. Johnny is marching home, as in the homecoming parade. He's marching at a steady 2 meters per second. He's been marching for 15 minutes. The parade route is like forever. All of a sudden it starts to rain, and everyone starts moving faster. By the time they make it into the field house, they're going 12 meters per second. It took Johnny 6 minutes to make it to the field house from when it started raining. How long was the parade route? The first thing is to realize you've got two parts here. When we're marching at a steady 2 meters per second, that means steady. That means the velocity is constant. If the velocity is constant, the acceleration is equal to 0. So we're going to write down the knowns that we have there. We have the velocity, and that's equal to 2 meters per second. And we have the time, and the time is 15 minutes. Of course, we immediately change those 15 minutes to seconds because we know we're going to need it. And then what are we hunting for? Well, we're hunting for how long was the parade route. So we want to know the entire parade route, but we have to get the distance for this particular section too. So we're going to have to find the distance here. And we call this distance 1 for the first part. Okay, that would mean this would be time 1 for the first part, and this would be velocity 1 for the first part. Then let's look at the second part. In the second part, it starts raining, okay, and everyone starts moving faster. Moving faster implies a change in velocity. And it says by the time they make it to the field house, they're going 12 meters per second. So the final velocity is 12 meters per second. And it says it took Johnny 6 minutes to make it to the field house from when it started raining. So the time he spent in this increased velocity is 6 minutes, which of course we immediately change to seconds. And also we still want to know what the distance is. Since this is the second time, we'll call this the second distance. Okay, now what it doesn't tell you, but what I'm implying and what I'm telling you as a teacher, because I wrote the problem, is that they had a constant acceleration, that they increased at a steady rate. So we have an acceleration here. Acceleration is not equal to 0. Let's go over to the first part and figure out this one. This one, since acceleration is equal to 0, we can use the old standby, v equals distance divided by time, which is an equation you can use only when acceleration is 0. In other words, distance is equal to time times velocity. Distance is equal to, so that one's easy to figure out. The distance is equal to 1,800 meters, but again, we've got to be careful. That's the first distance from the first part. Okay, I'm going to put it up here so it's easier to see. D1 equals 1,800 meters. But we have to add to that D1 D2, the distance that they covered when they were running when it started raining. To do this, we want to find a distance. There's not many distance equations we can use. Well, there is. There's the three, basically. df equals di plus vit plus at squared. We don't have an exact acceleration. We could figure it out, but maybe there's a bit easier way. Vf squared equals vi squared plus 2ad. But again, we don't have an acceleration, so maybe there's an easier way. And of course there is. There's the equation d equals 1/2 v1 plus v2 times t. What is v1? Well, v1 is the velocity at the start, right when it started raining. What was their velocity when they started raining? Well, it was 2 meters per second. So now we can write this in, we can do substitution. And we see that d2 is equal to 2,520 meters. Okay, so I'm going to write up here. And so now all we have to do is add the two together to get our final answer. And our final answer is 4,320 meters, which is like 4.3 kilometers, which is like 2.5 miles. 2.5 miles is a fairly long parade route. They were right. It was forever. Now we're going to go to our second problem. The freshman float is having problems. Everything starts out well when the float traveling a constant 15 meters per second for the first 12 minutes of the parade. Then the gas pedal gets stuck in the down position. causing the float to accelerate up to a speed of 30 meters per second in 28 seconds before it crashes. What was the total distance traveled by the float until right before it crashed? So again, we're looking for the total distance. Again, we're going to separate into two parts, the first part and the second part. Everything starts out well with the float traveling at a constant 15 meters per second for the first 12 minutes. Constant means the velocity is the same. That means acceleration equals 0. So we have the acceleration is equal to 0. We know the velocity in this first part is equal to 15 meters per second. We know the time in this first part is equal to 12 minutes. It says then the gas pedal gets stuck in the down position, causing the float to accelerate up to a speed of 30 meters per second in 28 seconds. So now we have an acceleration here. So acceleration is no longer equal to 0. It's not equal to 0. We have a final speed of 30 meters per second, and we have a time of 28 seconds. So we know the final speed, I'm going to call it VF, is equal to 30 meters per second, and we know the total time spent in this acceleration mode is 28 seconds. But we're looking again for the total distance traveled. So we're going to find the distance in the first part, and we're going to add that to the distance in the second part. In the first part, acceleration is equal to 0. So when acceleration is equal to 0, we can use the old standby v equals distance divided by time, d equals tv. Changing our minutes to seconds, we have 720 seconds for our time. That's important to do, otherwise we've got meters per second up here. So our distance 1 is equal to the time, 720 seconds, times the velocity, 15 meters per second, which gives us a fairly long distance, 10,800 meters. Over on the second part, we've got a VF, we've got a T, we're hunting for a D. We know there's acceleration, but we don't know what the acceleration is. We could calculate it if we want to, but I'd rather go with the shortcut method. I know that as it moves from part 1 to part 2, that the velocity at this point was 15 meters per second. So I know my starting velocity over in part 2 is 15 meters per second, and I can use the old standby, d equals 1/2 v1 plus v2t. I can't always use that equation, but it's working out well for these two problems. Substituting in, that gives me a distance of 630 meters. So the part 2 distance is 630 meters. Part 1 distance is 10,800 meters. I have to add them two together. And I get up here that my total distance is equal to 11,430 meters. And that's my answer. Thank you very much for your time.